Thank you for the kind welcome. I am David Long from the United States, and as we talk about this journey, I think it's worthwhile to talk about global trends in the area of architecture. In 2014, INCOSE published Vision 2025, trying to project the state of the world, now just 5 years away, and how we must evolve to successfully meet the business and the societal challenges. One of the areas that we identified was architecture. And in fact, the trend that architecture has begun to develop products that are more brittle, more difficult to use, harder, more expensive. Why has this trend emerged? And then more importantly, how do we address it? It's worth looking at the evolution of the products and the systems that we build. For years, we built standalone products, automobiles, tractors, trains, and we became very good at refining those product structures over years. Change was relatively slow, technology was relatively stable. Then we began to layer software onto the products to make them more capable, make them easier to use. In the process, we also made them more complex and harder to design, but we learned to deal with it. Today, we talk about the smart connected product, IoT, the ability to put sensors on every product, to control them better, to gather more data, to learn, to evolve. The complexity is growing. But now it's not enough for one thing to operate in isolation. We bring pieces together, pieces that are designed to work together to deliver a smoothly functioning Shinkansen. But now one more step. How do we bring the rail, the bus, the taxi, the infrastructure together to deliver mobility as a service? What we see is an evolution from electromechanical, which, while difficult, we learned to master, to cyber, to connected, to coordinated, and now to collaborating. In this, we have radically increased the scale of what we try to do. We have radically increased the complexity of what we try to do. And we have radically increased the diversity of the team required to conceptualize, build, operate, and support these systems. To do this without architecture, frankly, is impossible. To evolve, we need to understand and embrace the 6 steps of architecting. The first 2, enterprise perspective, which helps us define the purpose of what we're building and the definition of goodness, and operational architecture, both exist in the problem space. How do we properly define the problem so that when we deliver a solution, it meets society needs? Steps 3, 4, and 5, system definition, the logical architecture, think of that as the processes, the physical architecture, the hardware, the software, the people. Those are all in the solution space. I first want to talk about critical trends in the problem space, in enterprise perspective and operational architecture. Because if you don't define the right problem, it does not matter how good your answer is. 3 quotes from business and technical leaders about the importance of starting in the problem space. I will pick the middle one, Russell Ackoff, a business professor from the US. We fail more often because we solve the wrong problem than because we get the wrong solution to the right problem. as we begin to deal with more interconnected systems, as we begin to deal with more societal systems, defining the problem is much more challenging because what we do has ripple effects to the pieces around us. Likewise, the pieces around us have ripple effects upon us. And so this challenge of defining the problem and spending more time upstream to ensure that we do not create difficulties is more important than ever. The issue here, though, is it's not an engineering problem. Classically, architecture is thought to be the domain of engineers, and that is no longer true. What we have to do is work with the business leaders, the users, the stakeholders, the collaborators, the politicians, to truly understand the problem because we are dealing with entangled socio-technical issues. Sometimes they now do not call them cyber-physical systems. They call them cyber-physical social systems, and social is the hardest part. So we are far beyond the engineering space, and as Andrew McNaughton, Chief Engineer for the UK High-Speed Rail 2 program said, and High-Speed Rail 2 can be thought of as Shinkansen built today connecting London and Birmingham. The issue here, why, is not an engineering decision. Why is a business, social, or political system, which means we must elevate it at the societal level. And in this phase, actually, we're not solving the problem. We're coming up with many, many reasons why many solutions are not acceptable. 95% of what we're doing is excluding possible solutions because they violate some societal or business need. The other trend to note here in the problem space is if we are interacting with other products, other systems, other infrastructure in order to deliver a new capability, we have to think at much larger than a product scale. We must think at mission level. It's not about how I build a better car. It's how I better help move an individual from their home location to their office. That's a different level of thinking. That's thinking in the mission space. If we move then to some trends in architecting in the solution space, what do we see globally? Historically, people develop new architectures for each product largely from scratch. That means they invent new solutions to create resilient, secure, and healthy systems. That is a very, very challenging task. So rather than reinventing, architecture, good architecture, and the use of patterns allows us to apply best practices, learnings from others to make our products, our systems, our capabilities more resilient, more safe from day one. So the use of patterns is critical, and it's enabled by good architecture. We used to think that we built to last. You build a system, it will be operated through time, unchanged, and then it will be retired. That does not sound like a cyber-connected system. We need to evolve. What our users want, the state of the world around us is rapidly changing, and as is technology. Tesla famously can upgrade the handling characteristics of your vehicle overnight. If they detect a problem, they can change it. You don't bring your car to the dealership, it happens over the air. If they want to deploy a new capability, it happens overnight. Architecture gives us the way to build in change, but also to understand and make change safely. if you do not totally understand how your system works and all those interdependencies in a complex system, you cannot risk change. But the reality is our products must evolve in the field. It was mentioned earlier that we're moving to modular and composable design. We cannot afford to design things fresh from scratch. We need to assemble good products, good technologies, good sensors, and bring them together with confidence to deliver something that our customers and our society needs. Again, architecture, by giving you that building plan of how do the pieces play their role, how do they coordinate, how do they cooperate, and how does the team that builds it coordinate, cooperate. Architecture is what allows us to move to modular and composable designs. That is the only way businesses can stay healthy. And I mentioned this in passing. We are changing our mindset from products to capabilities. It's not about building a better car. It's about better mobility. It's not about building a better tractor. It's about improving the food supply. Those are higher level concepts, and we move to those concepts because the automobile alone doesn't give us mobility. The tractor alone does not give us food. These pieces come together, again, in some cases coordinated, in some cases collaboratively, to meet the needs of business and society. That is only possible through a robust and thoughtful architecture. What happens if we get it wrong? I've been talking about why we want to get it right, but what happens if we get it wrong? It's always good to laugh at the Americans, and we give you plenty to laugh about. The first is healthcare.gov, the website to sell national health insurance. Cost approximately $576 million, and less than 100 people were able to use it on the first day. Some people would consider it an IT problem. It's an architecture problem because they tried to bring together multiple collaborating systems and they didn't know how to do it. Funny story, no one got hurt. Delta works for the Netherlands, a 40-year program to protect against flooding by the sea. The first year it was completed, the Netherlands suffered their worst floods ever from the backside because of rain and snowmelt. Very bad architecture because they did not understand the problem space. They solved one side and made the other side worse. Not as funny, but no fatalities. Samsung, the famous phone that you could not take on an airplane. $5.3 billion of economic impact to Samsung. Most people, myself included, did not think that Samsung could survive in the cell market after that. They did. Two fundamental architecture issues in that phone, one design, one production, both architecture. They were lucky to survive that. Chevy Cobalt, an automobile in the US, which had two problems. The first problem was the ignition would rotate while it was in motion, shutting off the power, which shuts off the power steering and the power brakes. The moment the ignition was shut off, it shut off the safety systems. So now you have a car in motion that's virtually guaranteed to hit something with no airbags. No longer funny. Many fatalities. Even worse, it took General Motors 2 years to understand that there was a connection between the ignition and the safety systems. They didn't understand the architecture. Boeing 787, an airplane grounded twice because of battery issues. I won't show an image of a 737 MAX, but we can certainly talk about it. There were many different issues on that plane, several of them architectural from day one. At the business architecture level, trying to effectively bypass certification because it's too long, too slow. From an operational level, trying to bypass training. From a technical product level, not understanding the interactions. 346 lives lost, untold financial damage to Boeing, complete loss of confidence in the U.S. Federal Aviation Agency, all of which is deserved. 5 very bad consequences, and there are countless more stories. We can't afford to continue that. As technology advances, as our society demands more from us, we cannot have these failures. So who's doing it right? How are we dealing with architecture, the digital transformation mentioned earlier, and this thought process moving from product to capability? Well, certainly there's a great deal in the aerospace and defense industry. It began in areas like NASA and JAXA on the government side, organizations like Airbus on the commercial side, and newer organizations like SpaceX, who have built this mindset of architecture and collaboration and digital in from the ground up. In the automotive domain, you're talking Tesla, and you're talking every other new player into the automotive market, which is bringing a new mindset, bringing pressure on every other automotive organization. Medical device field, telecom, any of these industries knows that they have to evolve because the problems are getting harder, the scale is getting bigger, the technology is more interconnected. You only stand a chance to deliver successfully with robust architecture. Several years ago, Stanley McChrystal wrote a book called Team of Teams, which is about collaboration in an organizational sense. But it's also about architecture. We cannot work effectively if we don't have an understanding of the whole. That's an architecture statement. Once we have that understanding of the whole, then the individual practitioners can make better decisions on their piece because they're informed of the impact and the interactions. I think we would like that in our businesses. Functioning in this world today where everything is interconnected requires that we understand and honor those holism, that holistic interconnection. Coming back in conclusion to those 5 challenges, it's very interesting. Certainly, we need to address that system architecture challenge by more thoughtful work in the problem space, better work in the solution space as we tackle bigger, more complex problems with more complex technologies. But as we solve that problem, as we leverage architecture, we also solve the first problem. Because the one time in a program that you can get a hold of complexity is the architecture. We address the fact that knowledge is lost because the architecture retains the knowledge, the purpose, the design, the objective. We help our organizations learn because, again, the knowledge is encoded in the architecture. And it's not only the collaboration of the product in the system, it's the collaboration of our team as we work together, business and engineer, practitioner and society, to deliver the world that we expect, the world that we need today. It's all due to good architecture. Thank you.